Okay, so let us now learn about interconversion, conversion between two different number systems. First we are going to look at conversion from decimal to other number system, decimal to others. Okay, so let us take a general decimal number. We all know a decimal number can have integral part as well as fractional part. So I am taking any general decimal number which has integral part as x2, x1, x0, 3 digits it is having, and it has 2 digits in fraction. This is a general decimal number. So how are we going to convert it into a new number system? We want it in a new number system with base r. Fine, any r can be any value, 2, 8, 16, any value. So what are we going to do is we are going to repeatedly divide this number with r. You divide this number, fine. You're going to get some quotient here. You again divide this with r and you continue it till you get the remainder as 0 or any number which is less than r, fine. So then you move like this. This is going to be the required integral part. Okay, and what do we do for the fractional part? You multiply it repeatedly with r. Okay, when you multiply this fractional part with r, you're going to get some integral part and some fraction part. You take this fraction part again and multiply again with r. Again you're going to get some integral part. You do it until you get a complete integral number. Okay, when you get one complete integral number, you stop and then you move from up to down. So this is going to be the MSB of the required fractional part, and this is going to be the LSB. Okay, let us look at an example now. We are given the question, convert 25.625 in binary. This number 25.625 is a decimal number. Let us look first at the integral part. 25 in this number is the integral part. See, how are we converting 25 in binary? We divide it repeatedly with 2. See, you divide 25 by 2, you get quotient as 12, remainder as 1. Then again you are dividing, quotient is 6, remainder is 0, 3, 0. Then you divide, quotient is 1, remainder is 1. See, 1 is not divisible by 2. So you get quotient as 0 and remainder as 1. So now what is the binary equivalent of number 25? You read it like this. Start from here and read it like this. So binary equivalent is 11001. 11001 is the binary equivalent for 25. Now look at the fractional part, 0.625. What are we going to do for the fractional part? We multiply it repeatedly with 2. 2 is the base of binary, that is why. Okay. What is 0.625 into 2? You get 1.25. You consider this 1 we take. What do we do with this 0.25? You multiply it again with 2. What do we get then? 0.5. Here integer is 0, so we consider 0 and 0.5 comes here. It is multiplied with 2 again. You get 1. See, 1 is a complete integer. So we get 1 here. Okay, and how do we read it? You read it like this. So the binary form for 0.625 is going to be 0.101. Okay, so what is 25.625 in binary going to be? It is going to be 11001.101. This is going to be the binary representation for this given decimal number. Okay. Okay, let us take one more question. You can practice it by yourself. I am giving the answer. Convert 19.125. 19.125 is a decimal number. Convert this in binary. Okay, you must get 10011.001. You try this. Try to convert this in binary. You must get this answer. Let us look at one more model of these type of questions. See, we have got 23.6 and these we have to convert in binary. First look at the integral part. We have to divide 23 with 2. What do we get as question? We get 11 and 1 we get as remainder. Again you divide 11 with 2. What do you get? You get 5 as question and 1 as remainder. Divide it again. What are you going to get? 2 and 1. Again you divide, you get 1 and 0. Fine, this is it. Now how are we going to move? We move like this. So what is the required binary? 1 0 1 1 1. Now come at the fractional part. 0.6. We multiply this with 2. What are we going to get? 1.2. So what is the integral part? 1. Then you multiply 0.2 with 2. What are you going to get? 0.4. Integral part is 0. Then you multiply 0.4 with 2. You get 0.8. Again integral part is 0. So you multiply 0.8 with 2. You get 1.6. 1 is the integral part. See, you got 0.6 again. You started with 0.6. You got 0.6 again. This means that this fraction is never going to end. It will never give us one particular integral value. So see, this is 1001. This is going to repeat. This is going to repeat again and again. So how do we write its fractional part? We write it as 1001 bar. You must have learned about this bar in basics in class 9th and 10th. Okay, so the same logic applies here. It's going to be the answer 1011.1001 bar. Okay.